Just as we could FOIL before, you may recall we multiply the first term through a times c, the outside terms, a times d, and then we distribute the second term. Inside, b times c, and the last term's b times d. As we do this with radicals, we want to make sure our final answer is always reduced. Let's take a look at some examples where we do just that. In this problem, we'll start by distributing the 3 root 7 through times the root 7. The 3 has nothing to be multiplied by, and so inside the radical, we've got 7 times 7, which is 49. Continuing to distribute through, 3 times 6 is 18, and inside the radical, 7 times 5 is 35. Distributing the 2 root 5 through times the root 7, we've got negative 2 root 5 times 7 is 35, and then negative 2 times 6 is negative 12 root 25. We now can look at simplifying this expression. You may notice we can take the square root of 49, which is 7, and the square root of 25, which is 5. We could have also done this by finding the prime factorizations of 7 squared and 5 squared and dividing those exponents by 2 to pull out 1 7 and 1 5. We now have 21 with no square root left, plus 18 root 35, which can't simplify, minus 2 root 35, minus 60 with no root left. As usual, we always want to combine like terms. 21 minus 60 is negative 39, and the root 35s are like terms as well. 18 minus 2 gives us 16 root 35. And we have our final solution. Let's take a look at another example where we have to use the FOILing method to multiply the radicals together. In this problem, we'll start by distributing the 2 root 9 through times the 4 cube root of 3. 2 times 4 is 8, and under the cube root, we have 9 times 3, or 27. 2 cube root of 9 times negative 1 is negative 2 times the cube root of 9. Remember, negative 1 is outside the radical, so it does not get multiplied by the 9, but only the 2. 5 times 4 cube root of 3, multiplying the coefficients, 5 times 4 is 20, cube root of 3, and finally 5 times negative 1 is negative 5. We again will make sure we can reduce as much as possible, and we can take the cube root of 27, which is 3. We could have also done that by finding 27's prime factorization, which is 3 cubed. Dividing the exponent by the index tells us 1 3 would come out. The cube root of 9 does not simplify because 9 is 3 squared, and we can't divide that by the index of 3. We now have 24, with no radical remaining, minus 2 times the cube root of 9, plus 20 times the cube root of 3, minus 5. We can now look at combining like terms. The 24 minus 5 is 19, minus 2 cube root of 9, plus 20 cube root of 3. With no like terms remaining, this will be our final solution. Just as with normal variables and numbers, we can FOIL with radicals, making sure our final answer is always reduced.